Hello everyone, myself Anjali Arya from MTech IT 5th SEM. I will be discussing all of the question from my end SEM examination paper of data science. I will explain all the important questions from the data science and semester paper, and I will give a clear conceptual and exam friendly explanation so that it will be easy to understand. So these are the two scenarios which are given to us. First scenario is of IPC or BNS session prediction. We have 50,000 past buyers with features. First feature is victim age. Second is gender. Its relationship with accused. Dowry demand, yes or no. Injury type, weapon used, threats on phone, time since marriage, and final IPC or BNS session charged by court. Second scenario is student performance prediction. We have data of 5,000 engineering students with the features attendance percentage, internal test 1, test 2, test 3 marks out of 30 each. Video assignment submission submitted for after each internal test, which is yes or no. Lab activity score 0 to 20. Online quiz average score. Final end semester marks, which is 0 to 100. Target a variable. So every questions of this end semester paper is based on this two scenarios only. We will solve every question based on this two scenarios only. First question of distinguish between hypothesis driven and data driven paradigm in data science. Provide an example of each. Hypothesis driven approach begins with the theory or assumption. It's IP. Its use case in first scenario, which is IPC or BNS prediction. Its example is lawyer assume if marriage is less than 7 years plus burn injury, then the IPC 304B is applies and collects only such evidence. For student performance example, hypothesis driven will be teacher assumes attendance is less than 75%, then the student is failed and only check attendance of failed students. Data driven example of IPC or BNS prediction for data driven is feed all 50,000 FIRs into machine learning. First model discovers model discovers dowry demand plus suicide note plus threatening call within 7 years. And second one is 97% and chances of BNS 80. Nobody thought of suicide note earlier. For student performance example of data driven is model discovers student who submit all three video assignment pass with 93 percentile and attendance is 60 percentile. Total new insights. For now, the part B of question number first is differentiate between structured and unstructured quantitative and categorical data with suitable real world example. So again, we have taken the example of these provided scenarios. For structured, the example of IPC and VNS is FIR Excel, case ID, victim age, Dory, which is yes or no, and section. For student example, student table is roll number, attendance percentage, test 1, test 2, and test 3. IPC BNS example of unstructured data is scanned FIR written handwritten pages, WhatsApp is chats. For student example, video assignment, file, lab observation, book scan. Quantitative for IPC BNS example, victim age, number of burns, injuries, call duration. For student example is text marks 24 out of 30, attendance percentile 82 percentile, lab score 60 out of 20. Categorical for IPC BNS example, relationship, husband, in-laws, weapons, knife and acid. Student example, video submission yes or no, and all this. Question number two, write an algorithm that utilizes Bayes' theorem for decision making. For student example, prior is P pass, which is equal to 0.75. P fail, priority of fail is 0.25. Priority of attendance less than 60%, 60 percentile is 60 percentile or fail is 0.85. Priority of probability of attendance less than 60 percentile of pass is 0.15. Student X has the 55% attendance, so probability of fail of low attendance is equal to 0.85 into 0.25 by 0.85 multiplied by 0.25 plus 0.15 to 0.75, which is equal to 0.65. So there is 65 percentiles of fail risk, that the student will have the fail of risk if he get the attendance, if he get the attendance of 60, less than 65 percentage. For crime example, probability of Drury death is equal to 0.7, 0.12. Probability of burn plus marriage is less than 7 years of 7 years for Dory death, which is equal to 0.95. Probability of burn plus marriage less than 7 years, which is not equal to naught, which is 0.08. If both present, then 61% charges of dowry death. Second part of question number two, which says that write any suitable algorithm for association rule mining that can predict all these association rule. Write any suitable algorithm for association rule mining that can for association rule mining that can print all the association rule. Assumption we have taken: minimum support is 5%, confidence is 80%. For crime rules, dowry demand is equal to yes, marriage is less than equal to 7 years, burn injury is there, then the BNS 80 percentage, confidence 96 percentile is weapon, which is equal to country pistol, land is dispute is equal to yes, and BNS 1031 murder, confidence of 91 percentage. Student rule के लिए for student rule, video assignment 1 is equal to yes, video 2 is equal to yes, video 3 is equal to yes. Then the end sum, and if end sum is greater than or equal to 70, then the confidence of 94 percentile. Test 1 is less than 12, quiz average is less than 40 percentile, then end sum is less than 40 percentile, then it's fail, configure 95, 97 percentile. Input we have taken transaction database D, minimum support threshold, minimum confidence threshold, minimum dash confidence. Output is all association rules that satisfy support is greater than or equal to minimum support, and confidence is greater than or equal to minimum confidence. A priori algorithm for association rule mining. Step 1 is generate frequent item set, generate candidate one item set, scan the dataset once to count the support of each individual item. 1.2 1.2 is prune to obtain frequent one item set L1 for each candidate in C1. If support is greater than or equal to minimum support, then keep it in L1. Step 2 is iteratively generate larger item set. For k is equal to 2 comma 3 until no more item sets can be found. 2.1 is candidate generate join step. Join L of k minus 1 with itself to create ck. Ck is A union B by A, which is an element of L of k minus A. B is the element of L of k minus A, where A and B differ in only last item. Pruning is step remove any candidate whose k minus 1 subset are not all frequent. Count support. Scan the database to compute support for each candidate in CK. Create frequency item set LK for each item set in CK. If support is greater than or equal to minimum support, that then include in LK. Repeat until LK becomes empty. Step 3 is generate association rules. For each frequent item set F with modulo of F is greater than or equal to 2, then generate all non-empty subset S of F. For each S, let rule be S supposed to F minus S. Compute the confidence. Confidence tends to F of S, which is equal to support F by support S. Rule selection. If confidence is greater than or equal to minimum confidence, then rule is accepted. Now moving to question number 3. Compute mean, median, mode, and standard deviation for a given small dataset. Explain when each measure is appropriate. For calculating the mean, median, mode, and standard deviation, we have assumption that test 1 marks of one batch 30 students. For one batch contains 30 students. 4, 6, 8, 10, 12, 12, 15, 18, 22, 28 up to 30. These are the data of the students. So we have calculated the mean, which is 13.5, pulled down by weak students. Median 12, real, which implies that real feature of average student. Mod is equal to 12 and standard deviation is equal to 7.2. So if it is high spread, then teacher knows batch is uneven. Same logic for number of Dory complaints. Question number 3. Question number 3, part B. What is the difference between error and artifacts in data cleaning? Explain any two imputation techniques. Error are error for the again we have taken the scenario 1 and scenario 2, which is age for crime example. Error can be age typed 150 instead of 15. For a student example, error can be test 3 marks entered 83 instead of 838. For crime example, artifacts can be all photos exposed because police flashlight. For a student example, artifacts can be quiz scores suddenly 100% because server showed answers. For crime example, imputation technique 1 will be mean age of married women in that area. For student example, imputation technique 1 is equal to fill missing test 2 with average of test 1 and test 3. For crime example, imputation 2 will be KNN find 5 similar cases, copy their age. For a student example, imputation technique will be KNN will be 5 students with similar attendance and test 1 copy their test 2. Now let's move to question number 4, part A. Explain any 4 common feature engineering techniques for continuous and categorical data. We have again taken two data, which is crime example and student example. Winning for crime example, winning is marriage duration is less than 1 years, 1 to 7 years, and which is greater than 7 years. Student example, total internal is equal to total internal will be calculated by total internal will indicate low if less than 40, medium if 40, medium is 40 to 60, high is greater than 60. Prime example, one hot encoding relationship will be husband, mother-in-law, and father-in-law for prime example. And for a student example, one hot encoding will be video submitted, then video one, video two, video one if yes, video two yes, and video three yes. For crime example, interaction features will be Dory demand and burn injury. Very strong predictor. For a student example, attendance multiplied by average test multiplied by all the videos submitted. Super features. For crime example, scaling is victim age, number of threats, which implies that mean is 0 and the standard deviation is equal to 1. For a student example, all marks and attendance scale before. For question number 4. Question number 4, B part. What is sampling from a distribution? Describe inverse transform sampling or Monte Carlo sampling with an example. Assumption: simulate 10,000 possible ends and marks for a week. Student use inverse transform to generate marks from past distribution. That is, college can say that there is a 80% chances he will stay pass. When we sample from a distribution, then we generate a random value that follows the statistical pattern of the distribution. For example, if a victim age in your 50,000 FIR dataset follows, then the mean is approximately 28, standard deviation is approximately 8, and distribution shape roughly normal. Then sampling from this distribution means generating new artificial ages such as 27, 31, 35, 18, and 29 that statistically resembles the real data. This is used for simulation, bootstrapping, synthetic data generation, and Monte Carlo risk analysis. Inverse transform sampling is a method to generate random samples from any distribution as long as you know its CDF, which is cumulative distribution function. Steps are: first, to generate a uniform random number, which is uniform 0, comma 1 by sim of uniform 0, comma 1. Compute x is equal to f minus 1 ux. F is f square minus 1. From this formula we can formula we can find the inverse. For CDF we can x is a sample form which is the desired distribution. For example, from your FIR dataset, which is scenario 1, suppose time since marriage in your dataset has this example cumulative distribution. Concept for sampling concept for sampling for from a distribution. It means that generate random data resembling real data, and in FIR scenario it creates synthetic victim age, injury types, and threats, etc. For inverse transform sampling, it's meaning that use inverse CDF to sample from any distribution. In your FIR scenario, sample time since marriage from its CDF. Monte Carlo sampling means simulates many random scenarios to estimate probabilities. And in FIR scenario, it estimates probability of BNS 80 given uncertain FIR inputs. Moving to question number 5, which is distinguish between parametric and non-parametric models and supervised and unsupervised learning with examples. Again, we have taken our two scenarios, which is crime example and student example. Parametrics and supervised learning. Its example in crime example is logistic regression, which predict BNS 80 probability. In student example, we have used linear regression, which is predict exact and some marks. In crime example, non-parametric or supervised learning, non-parametric and supervised learning, we have used the random forest for best accuracy or for section. In student example, we have XGBoost 94% accurate grade prediction. Unsupervised in crime example, K-means clusters FIR is into five types, five crime types, and in student example, K-means cluster is student into struggling last minute. Question number 5, part B. Define accuracy, precision, recall, F1 score, and illustrate their computation using a confusion matrix. TP is the model correctly predict positive. FP is model correctly incorrectly predicts positive. FN is model incorrectly predicts negative. TN is model correctly predicts negative. This is the table for the prediction positive and negative. Actual positive is TP and TFN. Actual negative is FP and TN. Here are the values for TP and TP, FP and TN are given, which is 80, 20, 10, and 90. Accuracy will be proportion of all the prediction that are correct. So accuracy formula will be TP plus TN by FN plus TP plus TA plus TN plus FP, which is equal to 0.85 for this given data. Precision out of all predicted positive cases, how many were actually positive? Precision is TP by FP plus TP, which is approximately 88.9 percentile. Recall sensitivity or true positive rate out of all actual positive cases, how many did the model correctly identifies? Which is recall formula will be TP upon TP plus FN, which is equal to 80 percentile. F1 score states that implies harmonic mean of precision and recall. Useful when the dataset is imbalanced. It is used when the dataset is imbalanced. F1 formula will be F1 is equal to 2 into precision multiplied by recall by precision plus recall. For in this case, it is 0.8. Meaning of this term matrix and its formula and example values what we have gained from this data. Accuracy is overall correctness, how much the overall correctness in the data is there. Formula is TP plus TN by all samples. Example value we have get 85 percentile. Precision meaning is correctness of positive predictions. How many positive predictions are there in the data? Formula is TP upon TP plus FP. Example value is 88.95%. Recall is ability to find actual positives. Its formula is TP upon TP plus FN. Its example value is 80 percentile. FN score is balance of precision and recall. Its formula is 2 into PR upon P plus R. Its example value is 84 percentile. Question number 6 describes how the coefficient in linear regression are estimated using either the closed form equation or gradient descent. Linear regression model we have this is the linear regression model for a data set with feature x and target y is equal to x beta, where x is input matrix m into n, beta is the vector of coefficient n into 1, and y is the predicted output. Goal is to choose b that that minimizes the mean square error MSE, which is J of P is equal to 1 upon 2m. And this is the formula we have derived from this. Closed form solution, which is also called normal equation. This is the normal equation for the data. Steps is compute x of t x, compute the inverse x of t x of inverse, multiply by x of t, multiply by y. This directly gives the coefficient estimate. Its advantages is it extract solution, no learning rate needed, and good for a small or medium data set. Its disadvantages is that it requires matrix inversion. It is slow for large data set, which is n is n is greater than or equal to 10,000 data, which is very huge value. Its example is suppose that we have taken a data here x and y. X value is 1 to 3 and y value is 2, 3, 6. Add bias term, we have x is equal to this is the x matrix and this is the y matrix. We have computed b is equal. Now the cost function used here is j of b, which is equal to 1 upon 2b x of x beta minus y up, minus y to the power t multiplied by x beta minus y. Gradient of cost function, that of g of b G of beta is, which is equal to 1 upon m x of x of t x multiplied by beta by beta minus y. Gradient descent update rule. This is the gradient descent update rule where alpha is learning rate and repeat until convergence. This is the gradient descent methods. This is the formula for cost function, formula for cost gradient of cost function, gradient descent update rule. Describe how the coefficient in linear regression are estimated using either the closed form equation or the gradient descent. These are the steps for the linear regression estimation. First is initialize coefficient, example zeros. Then compute prediction, y is equal to x beta. Compute the gradient, j is equal to 1 upon m, x of t, y, y of minus y. Update coefficient, b, b which is equal to b minus alpha g. Repeat until the cost is 12. Features are speed, exactness, require matrix inverse, works well with, and the memory. Speed with the closed form or normal equation is fast for all for small n, and gradient descent speed is good for large n. Exactness is in closed form is exact, and for gradient descent it is approximate. Requires metric inverse for closed form is yes, and for gradient descent it's no. Works well with the closed form, which is greater than 10k features, and the gradient descent is millions of features. Memory for closed form is high, and for gradient descent is low. Question 6, part B. Explain logistic regression and use the logistic function to calculate the probability of a class for a given input example. Logistic regression is a classification algorithm used when the input is binary, that is yes or no, 0, comma 1, fraud or no fault, BNS 80, not BNS 80, etc. These are the types of the outputs. It predicts the probability that an input belongs to the positive class. The formula for it is P of y is equal to 1 or x, which is equal to P dead. It does this by computing a linear combination of features, which is z is equal to b naught, b1 x1, b2 x2 to bn xn. Passing z through the sigmoid logistic function mm, to convert it into function, which is sigma of z is equal to 1 upon 1 plus e to the power minus x minus z. Logistic sigmoid function. The sigmoid function converts any real number into a value between zeros and 1, which is p naught is equal to 1 upon 1 plus e to the power minus z, where p that predicted probability of class 1. If p dot is greater than or equal to zero point 0.5, then it predicts that the class is 1. If p naught is greater than or equal to zero point 0.5, then it predicts the class is 0. Suppose we build a logistic regression model to predict it a case falls under BNS 80 Dory death. Then the model coefficients are intercept, whose symbols is beta 0 and its value is minus 2.0. Dory demand if 1 if yes and 0 if no. Then the symbol is beta 1 and the value is 1.5. Merigius symbol is beta 2 and its value is minus 0.3. One injury, 1 if it is yes and if it's no, then 0. Symbol is beta 3. Its value is 2.1. The input example for FIR case in Dory demand, its value is 1. Marriage years, it's 2. One injury, it's 1. Then these steps are compute the linear score z is equal to beta 0 plus beta 1 x1, beta 2 x2, beta 3 x3. Putting the values, we have got the value of z is equal to 1.0. Now apply the logistic function, which is p is equal to sigma of 1.0, which is equal to 1 upon 1 plus e to the power minus 1. Now we have put the values, and we have got the value of a p naught is, which is approximately 0.731. Final prediction is P of BNS 80 is not equal, or X is 0.731. Logistic regression. Logistic regression is the model for binary classification. Linear score Z is the weighted sum of inputs. Sigmoid function converts a score into probability. Output is the probability of class 1. Question number 7, part A. Write the k-means clustering algorithm. Discuss how initial centroid influence result. K-means for IPC scenario. K-mean, again we have taken the IPC scenario case, which is crime clustering. Its goal is to cluster 50,000 first information reports FIRs into K natural crime groups. Example, death, honor killing, land dispute murder, to inform policy or BNS session prediction. Assumption and pre-processing features are victim age scaled, marriage duration scaled, dowry demand encoded, burn injury encoded, threat call count scaled, weapon type one hot coded, relationship with accused, which is one hot encoded. Data preparation is all features must be numerical and appropriately scaled or encoded use. Target K is the assumed range for K is 5 to 7 based on the expected numbers. The K iterative grouping engine for K-means is an iterative algorithm that partitions data into K clusters, minimizing the distance between data points and their assigned centroids. Its steps are initialization. First is select K random starting centroids, the center of the groups. Then assignment is step, which is equal to assign every data point in the nearest centroid. Third step is update M step, which is recalculate the centroid as the mean position of all the points assigned to it. Fourth is repeat. Go to step 2 until the centroids step moving. Again, we have the steps of initialization, setup and initialization. Set the best in interior found so far, I minimum to infinity. Second is initialize C crime boost centroid and L crime boost labels to known. Iterative clustering and selection repeat and runs times. Repeat for R is equal to 1 and N is equal to runs. That is, it has two methods, which is it has 2 points, which is a smart initialization. Select K initial centroid using K means and method on X crime. C of R is which is K means plus K X crime multiply by K. Iterative refinement run the standard K means procedure on the current initialization C of R. Key step assignment. Assign every FIR X1 to the nearest centroid M step update. Recalculate the centroid by averaging all FIRs assigned to it. Repeat each step and M step until convergence centroids no longer more significantly. Inertia in inertia calculation. After convergence, calculate the inertia of the resulting clustering from this formula. Select best result from this formula. Interpretation and deployment. Return C crime boost, L crime boost, and L and I minimum. Analyze the crime analyst must now examine the centroid C crime Boost, for example, a centroid with high Dorim demands low marriage duration and high burn injury probability. We labeled as the low Dory death group BNS 80. Scenario K means for scenario 2, which is a student learning analytics. Its goal is cluster 5,000 student into K learning behavior groups. Example consistent and performance. Struggling last minute heroes for timely intervention before the end semester exam. Assumption and pre-processing features are attendance percentile standardized internal test 1, 2, and 3. Marks standardized video assignment submitted, 3 binary lab score standardized online quick quiz average standardized data preparation all marks scored scores and the percentage must be standardized variance which is equal to 1 to ensure equal weighting. Target K is the assumed range for K is 3 to 4 representing the main behavior of the students. The iterative group engine for K-means. K-means is an iterative algorithm that partitions the data into K clusters, minimizing the distance between data points and their assigned cluster center centroid. Initialization. First step is initialization. Select K random starting centroids, the center of the groups. Second is assignment. Each step assign every data points to the nearest centroid. Update M step, recalculate the centroid as the main position of all the points assigned to it. And the fourth step is go to step 2 until the centroid stop moved convergence. Steps of initialization is set the best inertia found so far, I mean to infinity. Initialize, say student boost centroid and L student boost label to none. Iterative clustering and selection repeat and non times. Repeat for r is equal to 1 and r is equal to 1 to and non. Smart initialization select k initial centroid using the k means plus method which is provided by this formula. Iterative refinement run the standard k means procedure on the current initialization c of r. Step assignment assign every student x to the nearest centroid and state update. Recalculate the centroid by averaging all student assignment to it. Repeat each step and M step until convergence. Inertia calculation. After convergence, calculate the inertia IR of the resulting clustering by this formula. Select the best result from this formula, and at last, interpretation and intervention is written. C student boost, I student boost, and I minimum. Actionable insights examine the centroids C student boost. A centroid with high standard deviation value for all the test and attendance perform group. A centroid with the low standard deviation value for all features in the struggling immediate alerts. A centroid with low test 1 by 2 marks but high test 3 lab quiz scores. uh, hero group uh, Hero group needs motivation for continuous efforts. Suppose your cluster affair is based on victim age, time since marriage, dowry demand 0 or 1, injury severity, numeric score. K means may discover clusters like cluster 1, which is younger victims less than 3 years of marriage, dowry related. Cluster 2, old victims, non dowry, no injuries. Cluster 3 severe injury cases leading to serious IPC BNS section. The centroids represent typical FIR profiles. Why initial centroids matter? Very important discuss point. The choice of initial centroid strongly influences first final cluster quality. K means optimizes locally, not globally. Poor initialization can trap the algorithm in a local minimum. Second, convergence speed. Good initial centroid implies fewer iteration and faster convergence. Bad ones implies many unnecessary reassignments. Cluster shape discovered different initial points may produce a different cluster, especially when cluster overlap. Data contains noise. Cluster differ in size or density. These are the cases, these are the ages and the Dory out of Dory, which is 1 or 0. For case A, the age is 22 and the Dory is 1. For case B, the age is 23 and the Dory is 1. For case C, the age is 24 and the Dory is 1. For case D, the age is 45 and the Dory is 0. For case E, the age is 48 and the Dory is 0. For case F, the age is 50 and the door is 0. Question number 7. Write the k nearest to neighbor KNN algorithm using Euclidean distance. KNN algorithm, which is classification method. Input we have taken training data set d of xi comma yi of d is equal to xi yi d is equal to xi yi. Query point is xqx, xqx and kkk. Algorithm steps. First, compute the distance for each training point. Compute Euclidean distance through this formula. Sort distance. Arrange distance in increasing order. Select nearest neighbor. Pick the k smallest distance. Voting or majority rule. Count labels among the k neighbors. The class with minimum votes become predicted class. YQ YQ is the majority label. K nearest neighbors. YQ is equal to text majority label and K nearest label. YQ is equal to majority of label nearest neighbor. Output is predicted class for XQX and QXQ. Question number 8, part A. Compare decision tree, random forest and boosting. Decision tree strengthens simple to understand interpretability, handles categorical plus numeric data, and it's fast training. Its weakness is overfitting, unstable, small change reflects to big change, lower accuracy. Random forest strength is it reduces overfitting, high accuracy, robust, works well on large data set. Its weaknesses is slower than single tree, less interpretable. Many trees require more memory. Boosting strength is very high accuracy, corrects previous errors, handle in complex patterns, best for competition. Its weakness is sensitive to noise, overview, and if not regularized, slowly. So the summary is decision tree is simple but unstable. Random forest is strong but less interpretable. Boosting is highest accuracy but is lower and is sensitive to noise. Question number 8, which is architecture and components of Hadoop, SDFS, Yarn or MapReduce, or describe Spark and its advantages over MapReduce. We have choice in this case. So we will first discuss Hadoop architecture. SDFS, Hadoop, a distributed file system, stores huge files across multiple machines. It is consist of name mode and data nodes. Split files into blocks 128 MB. Replication factor ensures fault tolerance. Second one is Yarn, yet another resource negotiator. Its components are resource manager which is a global master, node manager which is node specific resource manager, and application master which coordinates task of an application. It manages cluster memory CPU scheduling. Third one is MapReduce, programming model with two phases. First one is map converts input into key value pairs, and second one is reduce aggregates value of same key. For example, we have taken an example of word count. Here map will be word comma 1 and reduce will be sum comma sum counts. Now we will discuss Spark and its advantages over MapReduce. Apache Spark. In memory distributed computational engine, it is used. It supports SQL streaming and ML library graphics. Spark is in memory, it is extremely fast, whereas MapReduce writes to disk after every step. Interactive plus real-time processing in Spark, whereas MapReduce is only batch processing. Spark has APIs in Python, Scala, and Java, whereas MapReduce uses low-level Java code. Spark uses complex DAG execution, whereas MapReduce uses a strict map or reduce only. Spark is better for machine learning and iterations, whereas MapReduce is very slow for machine learning loops. Question number 9, part A, which is obtain basic logic gates from neural networks summarized in a table with neurons, activation function, and back propagation. Let's start with AND gate using perceptron. We have taken input x1 and x2. Weights we have taken x1 and 1 comma 1. Bias we have minus 1.5, and activation is a step. So for AND gate, the output will be 1 only when both the inputs are 1. For OR gate using perception, weight is 1 comma 1, bias is 0.1, then the output will be 1 if any of the input is 1. For NOT gate using perceptron, we have taken input which is x, weight is minus 1, bias is 0.5, and output is 1 when x is equal to 0. For XOR gate is not linearly separable, so we need a multi-layer perceptron, two layers. Now moving towards question number 9, part B. Compare CNN, RNNs, and GNS transfer learning. CNN, which is convolutional neural network, its architecture is convolutional layers, pooling, and fully connected. Its strength is capture spatial features, excellent for images, and its application is image recognition, object detection, and medical imaging. Architecture of RNN, neural network, is loops in architecture and hidden state. Its strength is handle sequential data, temporal patterns. Its application is text speech, sentiments, time series. GNS, adversarial network. Its architecture is generator plus discriminator, which is a two networks. Its strength is generates realistic data, unsupervised creativity. Its application is image synthesis, deepfakes, and data argumentation. Transform learning. Architecture is retained model used as base. Its strength is saves training time, high accuracy with little data. Its application is small data sets, fine tuning, and NPN models. Thank you for listening.